Here is a beaker filled with water. We know that gravitational pull applies downward force on any object. For example, when I release the ball, it falls to the ground due to the gravitational force applied on it in the downward direction. Similarly, the gravitational force is also acting on the water inside the beaker, trying to pull the water down. What does force cause? Yes, pressure. This force causes pressure in the water, and this pressure is not constant throughout. For example, consider 2 points A and B. Will the pressure be more at this point A or this point B? Have a guess. The pressure will be more at this point B. In order to understand this, let us divide the water into different layers from top to bottom. There is a downward force acting on each layer. Due to this, each layer is pushing the layers below it in the downward direction. That is, each layer is applying a pressure on the layers below it in the downward direction. The top layer of water is applying downward push on each of its below layers. Similarly, this layer is applying pressure on the layers below it. Point B is in this layer, and there are more layers above B than there are above A. Or in other words, the weight of water above point B is more than the weight above point A. Hence, more pressure is acting on B than A in the downward direction. So we learned that water exerts a pressure in the downward direction. But is downward direction the only direction where water exerts pressure? Let us do one experiment to answer this. Say there's water kept in a plastic container. Let's divide the fluid into 5 equal layers and make a hole in each layer. What do we notice? The water is leaking out of the 5 holes, which must be pretty obvious to everyone. But the reason for this leakage is the pressure that the water is exerting on the walls of the bottle. Yes, the water exerts pressure on the walls of the bottle too. So the liquid exerts pressure not only in the downward direction but sideways too. Moreover, notice the distance covered by the water flowing out from each hole. The water coming from the bottom hole covers the maximum distance, while the distance decreases as we go towards the top. What does this tell us about pressure? This tells us that pressure is higher at this point compared to other points. The pressure increases as we go downwards. Let us see one more experiment. Take another filled bottle and make a few holes in it at the same level. Observe the water coming out of these holes. The water from each hole covers the same distance. What does this tell us? This tells us that the pressure exerted by the water at the same depth is the same in all directions. That is, if I take few points all at equal distances from the base, then the water at these points will exert equal pressure in all directions. Now try drowning a plastic ball in the water in a container. It will come up every time when you let go of it. This tells us there is upward force acting on the ball. This is called buoyant force. You will learn more about this force in higher grades. So far, we have only talked about water. So let us take 2 plastic bottles, one filled with water and the other filled with kerosene. Note that both the bottles are identical in shape and size. Make a hole in both the bottles at the same height. That is, this distance is the same in both. The liquid is flowing out from the holes. Measure the distance the liquid travels in each case. You find that the water covers more distance. Can you tell me the proper reason for this? The reason is that the water applies more pressure on the walls of the container than the kerosene. So what did we learn from this video? We learned that liquids also apply pressure and that they exert pressure in all directions. Does air also exert pressure? We will see that in our next video.